So as soon as you click step into, you should see the disassembly part here, and make sure that in the viewing option you have turned off the show addresses, because we don't need that. Step into, and again when you click here. Hey everyone, so in the last video we saw how to generate a custom shellcode from C language. Now the problem with that shellcode is that although we can use that shellcode in normal applications, there are some cases where we cannot use that type of shellcode. For example, there is a malware which is called a dirty vanity. It's not a malware, it's basically an approach. So in this approach, what happens is that instead of injecting shellcode in the main process, whichever process that may be, we inject the shellcode in a forked process. So what is a forked process? You might know that instead of we make a duplicate of the same process. It's called forking in the Linux, but as in Windows there is no exact equivalent of forking. So Windows using its own process. So therefore, when we inject the shellcode generated here in this technique, that does not work in the fork process of in the dirty vanity. So the reason for that is, if you go through this article here, I will link this article in the description as well. So if you go down, it first explains all the approach of the dirty vanity, how it works. So you see this is the explorer, and this is the fork process. It's called article clone. User process is basically a clone of the main explorer. As I mentioned earlier that there is no equivalent of forking in the Windows. So for that purpose, Windows using the cloning approach. So if we go down here, so you see this line here that the shellcode was forked and executed, yet the internals of user 32 message box A failed to operate from within the fork. So this approach was using basically shellcode in which they were displaying a simple message box within a shellcode, and what was happening that the message box shellcode was failing in the fork process. So the reason for that is described shortly here as well, that the user message box A needs the get shared info structure to be mapped to the process. Now the Explorer XZ has this structure mapped within the main process, but when you clone the Explorer process, this structure and some other structures as well do not get mapped to the new clone process. As they link here as well, that the view unmap will not be mapped into the child process. So there are some structures which are not properly mapped into the cloned or the fork processes. So that's why the normal shellcode does not work well in this approach. So that's why we need an position independent, totally self-sufficient code which does not depend on the other structures, so that we can execute that shellcode in any process that we want. So for that purpose, they are referring to this template here. Now this template is basically a custom template which is used to create, as it mentions here, a custom anti-DLL based shellcode. And this shellcode is performing anti-DLL API from the LDR. Then it performs parameter creation, and then it invokes the anti-create user process. And in that user process, they are running this command here. So this is the main template that they are using in their shellcode. However, this is not it's a bit complicated. So for that purpose, the Dirty Vanity has provided its show source code as well, and this is a bit customized template that they are using from the original one. As you can see here, this is the custom shellcode, and you can see that in the source this is a simple C file. However, when we go to the source in the Dirty Vanity, you see the macros and anti-DLL and other headers as well. So this is the main repository that we are going to use our own anti-DLL based custom shellcode, which we can inject in the other processes, right? So the first thing that we are going to do is cloning this repository into our local directory. So once the clone is complete, we are going to open it in the Visual Studio. All right, so you might need to retarget the project as this is a bit older version, so we might need to retarget it. Okay, let's try that. All right, so we have cloned the dirty vanity code and opened in the VS code. So the first thing that you would notice here down, if you scroll down a bit, and there should be something, yeah, it is. So this is the line basically where they are generating the command that they want to inject, and this is the string that is being represented as the hexadecimal. So what we need to do, all we need to do is to basically just change this string and our shellcode should be good to go. So what we are going to do is we are going to run the same command. Let me copy it from here, and so instead of showing the message, we are going to get this system info.exe, and we are going to save it in the same folder with the name of this info.txt, right? So how do we convert this string into the hexadecimal? You can use the online tools as well, but I'm going to use my own utility which I coded in the C++. So let me just open that. Okay, so let me copy this string from here. I'll copy this, and I have the utility here called utils.exe, and I'm going to convert the string to hexadecimal Unicode characters. So I'm going to select 1 and I'm going to paste here. Now first thing I need to do is I need to remove these escape characters. These characters will be added automatically, so I don't need to worry about this, right? So okay, let me try it now. See, if you compare these strings are basically the same, 005C, and at the end there is a 005C again, and 0043, 0043 here, 69, 69, 77, 77, 79, 79, 60, 60, 63, 63, and now what I'm going to do is all the way till here, 0063. So this is the point, till here it's 0065. so till here it's basically our this string this substring till the command.exe. so this is where it ends. Now /k and then the system info, this is the one. So it starts from here, and this you see the difference starts from here. So it's 0073 and it's 0060. So basically this till text 7 will remain same for you because we are executing the command. So till text 7 the hexadecimal will be same. You don't need to generate the Unicode hexadecimal for these structures. For the later on we can generate our own other Unicodes. So it goes till here 0065, right? So what we need to do is we need to start changing from here. So I'll just start copying. Alright, so till here till the text 15 our shellcode is completed, and we need to leave the last text 16 as it is as a null terminator. We should not change that. So right now it basically sits exactly with the same within the same structure. So let's say if we are going to generate the shellcode for some other command, right? So let's say that the string that we are generating is a bit longer. Let me just generate shellcode in the public directory. We don't need to include the escape characters, users, public, and let's say we are generating the text file in the public folder. So when we generate for that, our strings will be a bit lengthy, right? So let's say that we have another string. Let me just so system info, let's say that we have an extra string that we need to add in here. So what we are going to do is we are going to call this w string and 136 dot text 16, and we can paste it here, and we will call it text 17, and so on. Whatever you need to add, how many you need to add, it does not matter. And you see there that we are getting the error here. So what we need to do in this case is we need to go upwards where it's defined. In here you see this, that at this place only 16 strings are defined, so once we add the text 17 here as well, so our error should go away, right? So let's say that you add text 16, 17, 18 until 20, 25, does not matter how long the command is. You just add the you just add the hexadecimal representation here, and then add the variable name in its in the definition of w string 136, and you should be good to go. But because our current command is just till here, so we are going to just remove that, right? So this is the first part that the first thing that you need to do is just convert the string from to the hexadecimal Unicode characters. And once we are done with that, we can go ahead and build it, right? So our build is complete. So one issue that you might face is, I'm going to show you right now, that when you are going to build the whole solution, right now we were building the solution from right here, so so it was building successfully. But if you go try to build the solution from here, you might get some error in the dirty vanity part, right, in here. So what we can do is try to remove that, because we don't need it basically. So let's try to remove that and see if the issue goes away. All right, so our build is now successful. So next thing we need to do is go to debug and step into. So as soon as you click step into, you should see the disassembly part here. And if you go back to the dirty vanity page here, then it basically tells you how to extract which part of the exe will be your shellcode. So if we go down here, you see that we are going to compile it and crop the shellcode template function bytes using our parsing tool. So these bytes are basically position independent shellcode, and then we can use that in the dirty vanity C++ or anywhere that we want, right? So basically the shellcode template function is the main byte that we are concerned with. So let's go back to the VS Studio and make sure that in the viewing option you have turned off the show addresses, because we don't need that, and also turned off the source code, because we also don't need that. Let's just leave that to checked right now. Let's step into, and again when you click here, yeah, so this is our shellcode template. As you can see here, this is the shellcode template function. It starts from 40 and 55. So right now we are in the function, so we can turn off the show source code. And this is the point. These are the bytes that we are mainly concerned with, right? So let me put it back there. So either we can copy the bytes from here, but in that case we will need to clean that. So I have an approach. Let's try that. So this is the part where the where function closes. So this is all the shellcode these are the bytes that we need. So we can copy this. Okay. can copy this like this, open the Notepad++. So we have pasted the text here. This is just temporary, we are not going to actually use it for now. And in here we can now turn it off like this. We go to the debug exe that we have here and open the CFF Explorer and drop the exe here. And in here we are going to section header and dot text, right? You know what, let's go to the sections and dump all of this, select all, and I'm going to copy it as C and C++ array. Go to the Notepad++ and paste it as the C++ array. So this is all of the bytes of the exe. Now we need to get the sequence of the shellcode function template or the required bytes which we have pasted here. So what we can do is we just need to find this sequence in our bytes. So I'm going to copy from here, that's fine. So you see that there is only one occurrence. We have our exact starting point at this point, so we don't need whatever is above this. So we can go to the top and we can cut it. So this will be the starting point for our shellcode. Now we need to find the endpoint, and again we go at the bottom and we so we can double check it here. 4880A5 4880A5 5300, oh sorry, 5803 and 580300 5F 00 and 5F 5DC3, right? So this is the part that that's the end of our shellcode. So we are going to again select all of what's below it. It's a long list, just to make sure that we selected all of it and cut it, right? So this is the shellcode. This is a small tiny shellcode that is our useful part. So we can remove this length because this is not right now correct. So this is the shellcode that we have extracted, and now this is completely independent anti-DLL based shellcode, and we can use it in the clone processes as well as in any other cases that we want that require a position independent shellcode. Just a heads up that sometimes this shellcode might not work because this is the debug exe. So you can experiment between the debug as well as the release version of the exe, but overall the process remains the same, that you need to just build the Unicode characters and build the exe and then extract the shellcode from the shellcode template function. So the rest of the process is the same. I will link the source code to my utils code as well, so that you can use it later on, and I will add all the other links that will be helpful to you in this process. So if you have any other question, you can just ask me in the comments. I will be happy to answer, and happy hacking.